Welcome back to Lines of Symmetry, number 43.
Okay. Y'all may remember symmetry from middle school or 5th grade. I don't remember exactly what grade level it's taught. Doesn't matter. You've seen it at some point, right? You with me? Y'all stay with me. Wake up if you can. Wake up. Lines of symmetry is something you've seen before, but now we're going to just get more mathematical with it. We're not going to just say, where can you fold it? Now we're going to say, what would the equation of the line of symmetry be? That's what we're leveling it up to geometry, okay? It's not enough to just say,
Well, if you fold the paper like this, it would match. Or if you fold the paper like that, it would match.
that's elementary. The level up aspect of it is, where can I draw a line and it would be symmetrical around that line? And now tell me the equation of the line. The first thing you need to know is there is vertical symmetry, which is what we practiced in the warm-up. Your warm-up had a line of vertical symmetry, and we said it was at x equals 5. Because if you fold it at that line of symmetry, these shapes would match, correct? You have to think of like that marker that has too much ink and you close it and it blots and you open it back up. Okay. Having said a vertical line of symmetry, there is a horizontal line of symmetry. Now with these two, the acronym that I taught you would be really helpful here. Which acronym would go for vertical? Yeah. So this would be VUX. If you've got headphones in, please take them out. This would be POI. So POI VUX is going to help you there when you're having to write the equations of the lines of symmetry. The next part is the new part that you've not seen before, where it's just a general line of symmetry. Now, we're not finding the equations of these random lines that are slanted. We are simply saying how many there would be. Okay? So if I gave you this hexagon and I said, draw all the lines of symmetry and tell me how many there are, you would create those lines that you see here, and you would be able to tell me how many you drew. So looking at it, you got the vertical, so that's one. You've got through here, you've got to imagine if I folded it, this would match, correct? Okay, so that's 2. Then you've got 3, nice and neat right there, fold. Then you have the horizontal, which is 4. Then you have this one, which is 5. Then you have this one, which is 6. So this example has 6 lines of symmetry. Yeah, for that. Yeah. And now, how many sides does that shape have? 6. You will notice a pattern with that. It only works with what's called a regular polygon. Regular means every line, every edge measures the same distance, and every angle measures the same measurement. That's what regular means. Scrolling down, we have a new vocab word, which if you have a highlighter, you may want to highlight to remind yourself, because this is a new vocab word. We have what's called point symmetry. This means, now don't focus on what's on the picture, focus on this is a rectangle. Would you agree?
Yeah.
Okay, if I was to have it laying down and I stuck my pencil right here in the middle, let's rotate this paper, and I rotated the paper, it doesn't matter which way you're going, do 180. 180, do I have the same image?
Yeah.
That is called point symmetry. You think of it as if I put my pencil in the middle and I just turned it at 180, is it the same image? And you can see with the example of a capital N, it is. So it's called point symmetry. Okay? So if any shape has rotational symmetry of 180, you need to be able to say, oh, that's called point symmetry. Y'all with me? Okay. So, rotational rotational symmetry of 180 means point symmetry. Okay? With me? Which brings us to the last type of symmetry, which is just general rotational symmetry. Okay? Rotational symmetry is when you take a figure and you rotate it around, and every time you turn a set number of degrees, it lands in the same shape. That's called rotational symmetry. Let me give you a very simple example first, and then we'll go to the more challenging one. Think of a square. So focus on just the black outer square. Y'all with it?
Yeah.
Ignore the shape on the inside, the hexagon. Think of the square. How many sides does a square have? Four. What's the smallest number of degrees I could take and turn a square and it would land back on itself? 90. Now, if you do 45, that means it's not going to land in the same spot.
Where's my work?
It might be the one that got thrown away.
What color was it?
Just a plain marble.
Yeah.
Something like this?
Yeah.
It's not yours. Mine.
All right. So look right here. You have a square. What's the smallest number of degrees I can take? Gosh, I had an actual square. What's the smallest number of degrees I can take? It's 90. One turn, right? Imagine if this was a square. One turn. Okay, what's another set of degrees? 180. What's another? And then another then.
360.
Okay. Rotational symmetry of regular polygons is always based on the number of sides, and then how many degrees is one full rotation? Of 360. Okay, so right here, to find the smallest degree of rotational symmetry, to find the smallest degree of rotational symmetry, how many degrees is one full rotation again? And then, why do you think we only had 4 answers when we did the square?
Only because it's 4 sides.
Okay. So I'm going to write 360. I don't know what happened. The screen just messed up. All right. I'm going to write 360 over n, and n stands for number of sides. 360 over n, I'm going to put where n equals number of sides. So if I say to you, what is the degree of rotational symmetry for a square? Your answer would say 90 degrees, comma, 180 degrees, comma, 270 degrees. And you can list 360, but you really don't have to because every shape has a 360 degree of symmetry.
What if it was like
It will always be a nice, even shape.
but what if it was like a pentagon where it's got like a different shape, like a different sides, and it would just be like.
I don't think you have to worry about us going into that many. Now, what if it was a pentagon? How many sides is a pentagon?
5.
It's 5. So you would do 360 divided by 5. Yes. Okay, go to the back. I want you to answer 1 through 6 Actually, honestly, you can answer all of them. So, but I know that some of you may need help with 7 and 8. Please use capital letters. It's asking for letters of the alphabet. Don't get technical with this and think, well, it depends on what font. It depends on who's writing it. Use capital letters of the alphabet, and I want you to think of like normal type font, like with B. Don't do this. The top one is small, just standard. Well, I want you to do it right now. There's a lot of letters. Number 1 has several answers. Number 2 has several answers. Number 3 has 4 answers. I want you to do this right now on your own, and then we're going to come together and say the answers out loud. But I want something on your paper. I don't want you working from scratch. 2 letters of the alphabet that have vertical line of symmetry. So this means you could take the letter vertical. What direction is that? Show me with your arms. If y'all get these switched, you're going to get the problem wrong. Vertical is up and down. Okay? Think elevator. Vertical. Okay. Where can you fold a letter right down the middle?
O.
O.
A.
H. I. M.
N.
I went no with U just because U tends to have the tail, even the capital U. If you draw a U without that little tail, like if you draw your U like that, then you're correct. If the U has that little like tail, then the answer would be no. So that one's subjective to how you write it. All right. W.
X.
Yep.
Y.
Yes.
Z.
No, not Z.
We fold Z.
Z can fold like this, not like this.
We fold Z. Ooh, can you fold Z?
No. No.
Visualize. Draw Z. Then you'll see it. You think you might be able to.
Oh, yeah.
There you go.
Yeah. No.
So for number 1, I got A, H, I, M, O, T, B, W, X, Y.
Why?
Yes.
Y. Hold it right down the middle.
Oh, right, a capital. I was thinking.
Capital, not lowercase. Number 2. Now we're doing horizontal. So that would be, think of it as a hot dog fold.
Yep. O.
B,
O.
C,
O.
O,
H.
H,
I.
I,
O.
yes, E.
O.
The only one y'all not said, I said was D
No.
and X.
How would you do a D?
D. You're welcome. Will it fold down?
What about E? E. A
You
capital
already said
E.
E,
Oh.
yeah.
I have a question.
Wow.
Oh, what's the one I was
So the answers are B, C, D, E, H, I, K, O, X. I'm assuming with a K that you are writing it from the middle.
Yeah.
You're assuming it's written from the middle, not like a lowercase. That wouldn't work. All right. Provide 2 letters that have both horizontal and vertical. So this was just a matter of you had to go back to your previous 2 questions and you had to list what was in both sets.
O. H.
You have H, I,
O.
O, X.
Oh.
B does not have vertical.
Nope.
Provide a letter of the alphabet that has, you have to think, point symmetry, which means you can hold, put your hand down, put your hands down. You can hold your finger in the middle and it can do 180, but not hot dog fold. So there's only one answer, all at once.
Yes.
S. S is one of those that you could hold right here and rotate 180 and it will match. But you absolutely cannot do a hot dog fold on it.
Why would it work? 'Cause now,
go to the front of your paper and visualize folding an N, like hot dog style up and
Yeah,
down,
that would work.
and you'll see that it's not gonna work.
Oh,
It's because of that line in the middle. What letter has infinite lines of symmetry?
oh.
Oh.
Oh,
Oh.
Oh. All right. This next question is very important.
Can I
There
go
will be
through?
questions.
Can you go through and draw those?
Oh no, because I was gonna actually just teach it. Like as we went over the answer, I was gonna teach because I want to have y'all write some stuff down. This next question is going to reappear in your test, which is next week, early next week. So you need to be ready.
Tuesday.
Yes. Draw. It was gonna be tomorrow, but
Dang it.
there's just too much going on, and I feel like it might be. I feel like you actually could do good because y'all done really good with your quiz. But I feel like oh yeah, there it is. I feel like it might be too rushed. Draw all the lines of symmetry for the following regular shapes. There's a vocab word in here that I need y'all to highlight. It has to do with the word regular, and what's sneaky about this word is it just kind of you read right over it. You don't think there's any context to it. If we're talking about a shape in geometry and it says the word regular in front of it, it means two things. It means one, all sides are congruent. It means two, all angles are congruent. And the term I tend to say here is it's pretty. It is a pretty shape because everything is symmetrical about it. It's not some like oblong triangle, it's a perfect shape. All the sides match in length. All the angles match in measure. It's called regular. And it is very easy to read over that word and forget that just gave you a ton of information, okay?
oh.
Look at the first shape. Yeah, just go to my desk. I'll get to you in just a second. Go to the first shape. We have a square here. They tell us that it's regular, so we know for sure this is a square, which means all four sides are equal, all four angles are
Equal.
and there you
90
go. 90.
degrees.
I want you right now, actually you should have already done it.
Yes.
You're supposed to draw dotted lines where, or solid,
Okay.
where you could fold it and it would match. Okay? Where you could fold it and it would match. Now, what type of shape is it?
Square.
So how many sides are there?
4.
4. We have a vertical line of symmetry right there. I could fold it hot dog style, or I guess it's not hot dogs, it's a square. We have horizontal line of symmetry. Because it's a perfect square, we actually could even fold the diagonal in both directions. So how many lines of symmetry did we just draw?
4.
It has 4 lines of symmetry. When I go to trace them, just count. Watch. 1, 2, 3, 4. You see how I've covered them all? You're seeing all of the. You're seeing the other side of them, and it's making you think there's more. There's only the 4. I want to add to this, y'all. I want you to come right here. I want you to tell me the degrees of rotational symmetry. List the ones that matter. So does 0 matter?
No.
0 does not matter. What's the other one that does not matter?
360.
360 does not matter. List them. How many should you list?
3.
It should be 3. If you forgot how to do it, it's 360 divided by the number of sides. And then you count by that degree measure. So it's 90, 180, 270. All right, how many lines of symmetry does this triangle have?
3.
3. You got the vertical, and you might think, well, I don't know where the others are. That's because you're thinking of it as upside, like, or right side up. Take your paper, turn it so that the next side is now the base. And do you see another line of symmetry? If you take your head, turn your head. Everybody tilt your head this way.
Found it.
Now this is the base. Do you see it right there?
Whoa.
Okay, now take your head and go this way.
Well,
Do you see it right here?
That ain't good.
So this has 3 lines. I want you now to come down here and list the rotational symmetry involved. Only the ones that matter. No, it is not the same.
Oh.
Why is it not the same?
there's 3.
There's only 3 sides.
60 divided by 3. Yes. You know
Yeah.
how to put that?
I just checked you, bud.
How many sides are there?
3.
3. Doesn't matter how many sides. What's the measure of one full rotation?
360.
One full rotation is 360. So when I do 360 divided by 3, I get what? Okay, so my list of rotational degree symmetry will come from that number. 120. How do you get the next one? You just add 120. You add it to it, so it's 240. How do you get the next one?
Add 120, but it's going to be
And you get what?
360.
I'm going to change colors here because the next one that you get at some point should be 360. I don't want you to list 360 because that's irrelevant, but you can get there as a checkpoint. If you don't hit 360, you've done something wrong. Every time it should hit 360, like right here, the next one would have been 360. Okay? So you could use 360 as a checkpoint as that you did it right. Go to questions 7 and 8. I want you to tell me 3 transformations that would, it says map the hexagon, not yet, not out loud yet, that maps the hexagon onto itself. 3 transformations that would put that hexagon right back onto itself. The letters don't have to match. It's just that the shape has to match, okay? You will notice that it is exactly centered on the coordinate grid. So, tell me, are there any reflections? If so, what's the equation of the line? Is there any rotation? If so, what are the degrees? So tell me, write that out on your paper. Try it. Looking at this shape, you with me? Y'all listening? Because it is exactly centered on the coordinate plane, would you agree that it's exactly centered?
Yeah.
Look at it. This is left 5, no, 4.
Left
Is that 4?
4.
1, 2, 3, 4. That's a negative 4. This is a positive 4. This is,
A negative 4. No, negative 3.5.
okay. And,
Positive 3.5.
okay. All right. So, it's exactly centered, right? Can you describe to me, you could even look at your paper and fold it. Can you tell me what's one fold? Vertical where? Specifically, what? Okay, a fold is called a what? What's the actual math word for it? A fold or a flip? A reflection. So we can reflect over, what did you say? The y-axis. Can we do it over the x-axis? What is the equation of the y-axis?
The equation of the y-axis.
Boy Bucks is going to come in here.
Y equals
Y-axis. Y-axis. What's the equation of this line right here? Bam. Vux, it's vertical, and it's crossing where on the x-axis? It's crossing at 0. So the equation of the y-axis is x equals 0. What's the equation of the x-axis?
Y.
Conversely, it's y equals 0. Boy Bucks would help you there. What is a rotational symmetry?
360 degrees.
Not for this. Well, yeah, that'd be boring. No, tell me one. What's the smallest?
60.
Why?
Because
You're not just throwing numbers out, are you?
No.
Okay, because that's going to confuse people.
60.
Why is it 60?
360 divided by 6.
Sides.
It is a hexagon. N is 6. So 360 divided by 6 would yield the smallest degree is 60. What would the next one be?
120.
How do we get this, y'all?
Add 60
We're
to
just
60.
adding.
And then plus 60 is 180.
Okay. Someone else chip in.
240.
Next.
300.
And next is your checkpoint,
What I mean?
right? Okay, coming to the next one. What's the shape? Parallelogram. Stay with me, you promise.
Is this the longest?
No, this is a parallelogram. That means it is elongated, right?
Rectangle.
It is a rectangle that has been
Shifted.
well tilted.
Tilted, shifted,
pushed.
pushed.
It is a parallelogram. It is front and center, right in the middle of the coordinate plane. Is there a single line of symmetry?
Vertical.
Well, look at it. If you reflect over the Y, you would count 1, 2, 3, 4,
Oh, okay.
2, 3. It would land here. So that won't work.
Horizontal one.
Okay, well this is 2 away. It would land here.
Okay, no. And it's just a. It's a
Of?
point symmetry.
Yes.
Yes.
A parallelogram has no actual lines of reflection, and that's because it's that rectangle that's. This is really fun to do, and it only took a moment. It's a rectangle that's shifted. So that means that there's no symmetry. One side is like protruding from the other side. Okay, so, but there is a point symmetry here. You could take your paper, everybody take your paper. Take paper. Look at the shape. Now turn it upside down. Is it the same?
Yeah.
Yes.
Yeah.
So it has point symmetry, which means 180 degrees. Now, what would it be rotating around if you did point symmetry? What? No, tell me what the point that you would put your pencil on to hold it.
The origin.
Point.
The origin story.
Origin. 0, 0. 0. 0.
Point symmetry stands for 180. All right. The next question is not a question at all. This is where math is used in the real world. Please look at, you just stole my thunder. Please look at these shapes. This is the word ambiogram, which by the way is what these are. These are ambiograms. This says algebra. This says mathematics. Now turn your paper upside down.
That ain't real. That ain't real. Come on, that's crazy.
And what do you notice?
Mathematics.
How is that? How does a C and S turn into an A?
It's the font. It's the font that helps to dictate how it looks.
What is that first word say?
You will know ambiogram, or some people call them ambigram. I call it ambiogram. you will notice tattoo artists like to do ambigrams because if I get a tattoo that says mom, and then I want to look and enjoy my own tattoo, it's going to say, wow. So a tattoo artist, a good tattoo artist, would not put mom on you so that when you look down, all you see is wow. You know, they would write it in a way that the font, when you turn it, would also say what you wanted it to say, okay? So that's just something really cool that I wanted to show you that, you know, when is this ever used? A tattoo artist uses like rotational symmetry so that the person wearing the tattoo and the people viewing the tattoo read the same word, okay? All right, we're going to put this up, and now we're going to go to the next paper,